This is number 58 in chapter 2. It looks at ions in this case. And so what we're trying to identify is, in this case, the number of protons and the number of electrons in each ion. And I'm going to do just part A and part B. Part A looks at aluminum plus 3. And so in order to figure out how many protons aluminum has, we have to go to the periodic table. And if we go to the periodic table, we see aluminum's atomic number is 13. So that means its number of protons is also equal to 13, because that's what makes it aluminum. And now we need to figure out the number of electrons. And so the number of protons minus the number of electrons is going to equal the charge that you see. In this case, that charge is plus 3. So if we rearrange this equation, we have the number of electrons is going to be equal to the protons minus the charge, right? Because if we bring protons over to the other side, we have charge minus protons, but then we have to get rid of that minus sign. So this turns into the number of protons minus the charge that is observed for the elements. And so our number of electrons would be equal to our number of protons, or 13, minus the charge we see, which is a plus 3. And so aluminum plus 3 would have 10 electrons and 13 protons. It has 3 protons in excess, and so that's why the element has a positive 3 charge. Part B looks at selenium. Selenium is Se, and this selenium has a minus 2 charge. If we look up selenium on the periodic table, we see it has an atomic number of 34, and so that's what identifies it as selenium, by that number of protons, which is the atomic number. So we have 34 protons, and then we're going to use the same equation above, that the number of electrons then is going to equal the number of protons minus the charge. So we have 34 protons minus the charge. What is the charge? It is minus 2. So those turn into an addition, and so now we have 36 electrons. Since we have 2 electrons more than the number of protons, that is why selenium has a minus 2 charge, since electrons are negative.